Good evening. I think we should probably start. I'm just going to say 2 or 3 words as the director of the School of Architecture. To introduce Ranulph Glanville's inaugural lecture. It's obviously a great pleasure and a very special moment for us, I guess also for Ranulph, to be here, because this will be the reflection of a long career, and it's for sure the reflection of a very high moment in Ranulph's career that we're going to share. And I mean, inaugural lectures are actually quite rare, because we have them in the School of Architecture maybe one every 2 or 3 years. And it's also known that quite a few professors, they take quite a while until they prepare these lectures. They present many years actually after being professors already. And we had quite a few cases in our school. Now, I think this is going to be a very special moment, and I'm delighted also that Stephen Gage will introduce Ranulph properly, as somebody that knows Ranulph for many, many years, and will give us quite an interesting insight into his career. Thank you, Stephen.
Hi, I'm going to be brief. I should say that the normal form for these lectures, I've been told, is that there are no questions afterwards, so you enjoy it and then we all go and have a drink or do something along these lines. Ranulph studied at the A from 1964 to 1971. He completed his PhD in cybernetics at Brunel in 1975 and obtained a second PhD in human learning from Brunel in 1988. He has recently received his DSc from Brunel. Now, for those who don't know about DSCs, they're honorary degrees given for outstanding work in a field. Max Fordham, who some of you may know, described it as standing for difficult science, and I'm sure that Ranulph won't agree and believes that his science is very easy. So Ranulph is a Dr. Cubed. He worked briefly as an architect in the UK and Finland and started teaching with me at the Architectural Association in 1972. We ran an intermediate unit, that's the equivalent of a BSc unit, under the slogan, "Architecture and intellectual activity are not necessarily mutually inconclusive." And I believe that there was a teacher to that effect that was printed. He taught for many years at Portsmouth University and then took to collecting professorships. He is our Professor of Architecture and Cybernetics, the research professor at the RCA, and is a visiting professor at St Lucas in Ghent and at RMIT in Melbourne. Ranulph is a Professor Cubed. He's published nearly 200 papers and is currently the president of the American Society of Cyberneticians. Ranulph is a collector of air miles. He's also a committed constructivist. So I personally look forward to constructing his inaugural from the world that he will present to us this evening, which will, of course, only exist for me in my construction of it. I'll pass you over to Ranulph.
Thank you, Marcus and Stephen. Air miles is the only currency I understand. It's the only one I've ever been able to save. I have some very charming friends who I worked with in Vienna, and they told me on hearing of this that I'm so near the end of my career at UCL that this can't possibly be an inaugural lecture. It must be an exaugural lecture. An inaugural lecture is one in which someone young and sprightly and fit and full of new ideas gets up and tells you how the world's going to be. And there have been some astonishing lectures given by very, very distinguished people in which they've really redesigned the world that we live in. Mine is sort of a tired old man's attempts to make sense of something. Before that, however, before I start trying to make sense, I need my Gwyneth Paltrow moment. I promise not to be quite as long. I talked with my family about this, and we decided I was just going to do big general thank yous. My biggest thank you is to all of you for coming here. I'm really touched that you have come. People have come from all four corners of the globe. It's an interesting notion, isn't it? And there are people here who have been my teachers. There are people who are colleagues. There are former students. There are current students. And there are people who just somehow or other came to be in the room. It's just wonderful to have you here. Thank you very much indeed. That's the Gwyneth Paltrow moment, except for one thing. I can't let this go without a sort of moment of special thanks to Stephen. Stephen and I, as he pointed out, have worked together in one way or another for a long time. And when I was thinking about how I could talk about this, the expression "through thick and thin" came to mind. And then I realized I didn't have an idea whether it was the thick or the thin which was difficult. So I did what we all do and looked it up on the internet. And I discovered, first of all, that one of the very first uses of the expression in English is here. It's Geoffrey Chaucer. But it originates from the phrase, "through thicket and thin wood." And so my thank you to Stephen is, thank you for being with me through thick and thin, and especially the thick. Good. End of Gwyneth Paltrow. No more Hollywood. I'm going to start just with a few words about the sort of person I was when I started studying and the sorts of things that I was interested in, because I find, looking now, that these are things which remain with me. Almost the first school that I went to was a kindergarten based on the teachings of Friedrich Froebel. Froebel was the inventor of the notion of kindergarten, and he was a very remarkable educator. He sort of tramped between Switzerland and Germany in the 1820s. And he believed, above all, that children knew how to learn, that they didn't have to be taught, that the teacher's job was to watch the child learning and then to help them in what they were trying to do. The teacher's job is not to tell people what to do, but to observe very carefully and act with the person who is doing the learning. And I used to talk about teaching from behind and things like that, and I have to say that that's pure Froebel. So from a very early age, I was indoctrinated, if you like, with this way of thinking. Now, this is not entirely unarchitectural. Richard McCormack wrote an article some years ago about Frank Lloyd Wright. Frank Lloyd Wright's mum was determined, A, that he should be an architect, and B, that he should have a Froebel education. And Froebel designed these sets of toys, which are called the Froebel gifts, which you go through. And McCormack suggested that if you look at Frank Lloyd Wright's architecture, you will see forms that come from the Froebel gifts. There are people who since have said this is nonsense. But to me, it's an interesting notion, and it brings us a little bit of architecture in the talk, which isn't going to have too much to do with architecture until at the very end. Now, the thing about Froebel is that he's really interested in the freedom to learn and the freedom to discover who you are and the freedom to be that person. He believed, for instance, that forcing people to do this or that or the other, forcing young children, led to all sorts of social and psychological pathologies. So he believed it was bad for people if they were taught. Yeah? It's a great excuse. It's a great excuse. And I find that in my work, and I'm now not talking about teaching, but in my work, there has been a thread of trying to set up frameworks within which other people could find their own way and express their creativity. And it's a rather peculiar business that you stand back, and rather than being creative yourself, you encourage everyone else's creativity. So that's actually a major part of what I want to talk about this evening. You may not see it immediately, but I hope it will become apparent. Well, the title is Freedom and the Machine, and it comes from this. A colleague of mine, when I started teaching, nothing to do with Stephen, I wasn't teaching with Stephen at this time, a colleague of mine said to me when I got my cybernetics doctorate that I destroyed everything. His belief was that there was a conflict between freedom and the machine, and that what I was doing was, by studying mechanism in the machine, I was destroying everything that was human. Now, freedom's a difficult concept. One of my teachers was the memorable Sam Stevens. I couldn't find a photo of him, I'm afraid. But Sam, I remember coming to tell me when I was probably in the third year, about an article he'd just read with, it was an interview with Chomsky. And Chomsky was trying to point out that the notion of freedom was very difficult. He said that, you know, for us in the West, freedom means that we can act as we'd like to and that the state supports us. And he said, now, you have to understand this and understand what freedom means for a Russian, because for a Russian it means something quite different. And the reason that we in the West and the Soviet bloc never understand each other is because our notion of freedom is totally different. Now, clearly I belong in that Western group, and I put the Chomsky contrast up because I just wanted to remind everyone here that we choose what we mean by things. And we have a choice in there. Freedom, according to the Oxford Dictionary on my Mac, is concerned with not being imprisoned and with self-determination. The machine is a little bit different. Let's see. Good. If I talk now, can you hear? Yeah? Okay. A lot of what we think of to do with machines is related to Newton. It's related to physics, it's related to mechanics, which of course is a word that comes from machine. And it has to do with this idea, for instance, that the solar system and probably the whole universe is somehow or other clockwork. It wasn't Newton who talked about celestial mechanics, that was Laplace. But Newton talked about rational mechanics in trying to describe the way in which the universe worked. And this, which is an orrery, which we've just seen, is an example of something which works entirely by clockwork. So there was a notion in the machine that it just continues, it runs, and that somehow or other we can have no effect on it. The machine that we all most know, I suppose, of this sort, really a clockwork machine, is based on this. This is Babbage's difference engine. This is really the first modern-day computer. And this is Doron Swade, who is the curator of computers at the Science Museum. Babbage designed this thing in the 1830s and 40s. It couldn't actually be built until they had a computer which could mill it. So in order to build this computer, you needed a computer. And it's difficult to have that when you're the first computer. So, in fact, it wasn't until they had this sort of computer that they could make Babbage's sort of computer. And here it is, a great big clockwork mechanism. And it was used for this. Now, probably at least half of you have no idea what this is. This is taken from a set of log tables. And these were the way, before we had computers and calculators, that we used to carry out sums. We used to look up the logs of numbers in these enormous tables and then add them up and do things with them. I can hardly remember what we did with them, but we did, and there was a sort of whole subject, logarithms. Now, these tables were produced by computers, but these computers were people. They were clerks who sat in rooms, and they would work through and produce the numbers that appeared in the tables, and of course they'd make mistakes. And that's why Babbage proposed his machine. I had some problem. I don't still have any log tables, so I looked them up again on the internet, and I discovered that log tables look like this, which was slightly worrying. Sorry for the pun, I had to have one. Yes. So that's what this machine was for, and it's why it's called a computer. It's because what it was replacing was a room full of people like you sitting there working out sums all day, in fact, entirely mechanically. These things should have been entirely predictable, and the idea was that this machine would not only make them faster, it would be more reliable. Now, we have a notion that comes with this sort of machine. It was expressed by Isaac Asimov in this book. And it is that such machines are things to be a bit afraid of. We are afraid of machines in some way, and hence the comment to me about me destroying humanity and so on. These are Asimov's laws of robotics. And they tell robots how they must behave, and they should be programmed into all robots to stop robots from being naughty and hurting us. Yeah. So we can go back and have a look at what the dictionary says about a machine, and you see that it's sort of extremely mechanical. Sorry about that. Now, this is a strange way of thinking about machines. I want to show you an advert. Many people think it's the best advert ever. It was shown in 1984, which, as you know, George Orwell's magic year, during the American Super Bowl in January. And what it does is it gives us a rather perplexing view of the machine. Here it is. Now, sorry, my screen went blank, so I had to press the next slide. You shouldn't, just close your eyes, pretend this isn't here. Be good people, do what I say. That was Ridley Scott, and what it was an advert for was this, the Mac. And what I think is interesting about it is that in this case, it's the people who are the machines, and it's the machine, the Macintosh, which is going to liberate them. And so this ad is in fact reversing our notions of what the machine is, what where the freedom lies, and so on. And that brings me to cybernetics. Now, cybernetics is often thought of as being very particularly concerned with machines. And I'm going to go through a little bit of what cybernetics is and then interpret this for you. I came across the subject because at the AA, I was told I had to design a supermarket. And I'd read Vance Packard's book, which showed all of us, just how manipulated we were by retail psychology. And I objected very much to this, and so instead of that, I designed internet shopping. It wasn't called internet shopping, but that's actually what it was, 1967. And one of my fellow students at the AA said, you need to go and meet a cybernetician. So I did. I went and met this very strange man, who many of you know. Either you knew him in person, or you know him by reputation. Gordon is the cybernetician who is most closely linked with architecture, design, and the arts, I think. And I went to see him in his suite of offices, and I told him about my project. In my mind, it took 3 hours, and it was totally incoherent, and he summarized it in 3 minutes with an extraordinary clarity. And I said to myself, this is a very clever man, but there's also something in that subject, and I want some of that. And so I came to be interested in cybernetics. Cybernetics is not a new subject. Most people think it is. If you have a look up here, you'll see that Socrates, for instance, used the word. And if you have a look down here, you'll see Ampere used the word too. There have been a lot of people who've used the word. It's Greek, Kubernetes. It means steering, a steersman or a cox. And the notion is that you can adjust error, that you can home in on a point. And so cybernetics seems to be primarily about steering. It's, of course, become a little bit, it's developed beyond that. In contemporary terms, cybernetics really is strongly associated with these 4 people. Gregory Bateson, Margaret Mead, who were married, Norbert Wiener and Warren McCulloch. And they formed the heart, or most of the heart, of a group of people who met first in 1942 and then from 1946 to 1953 under the aegis of the Josiah Macy Foundation in New York. And they met and talked about certain behaviors that they had found existed in common across many different sorts of systems and in many different fields. I have to be a little bit quick about this, so I won't elaborate further. But at a certain point, Wiener felt that there was a book in this, and so he moved out from the Macy. Well, he didn't really move out from the Macy's, but he by himself produced this book, Cybernetics, Control and Communication in the Animal and the Machine. It was the wrong book to be produced. It's so wrong that 3 or 4 years later, he felt he had to write another book, the book he should have written first, because the book that he wrote under the name Cybernetics is so technical and it's so mathematical that the point that he really wanted to get at was almost completely lost. And in a sense, we still have that division in cybernetics today. So there are, as you will see, 2 definitions I have here. There's Wiener's one, but at the top there's also the mission statement of the Macy conferences. And sometimes it's difficult to see the similarity between these. But all of the ways of characterizing cybernetics have this sort of strangeness. Wiener, by the way, gave it the name cybernetics, and he gave it that name just because he felt someone had to, as he says here. I'm going to put you up just a few other descriptions of what cybernetics is, and you'll see that they're quite different. I mean, the science of effective organization and the art of defensible metaphors. It's sometimes difficult to put those two together. But there is one last one that I want to bring to your attention. It's why it's bigger and in blue. And that's the study of all possible machines, which is Ross Ashby. And I put it there because cybernetics is thought of as being very much to do with machines. And that's really why I feel it's appropriate to talk about freedom and the machine in relation to cybernetics. I also like this at the bottom very much. Yes, I think there's something very charming about that. The man who did more to take money away from cybernetic research, put it into artificial intelligence, and produced nothing that ever worked, came up with this statement. Well done, Marvin. Sorry. He never impressed me very much. He was a very nice man. Okay. Come on, you're supposed to have moved on. There we are. I want to end up with two other ways of describing cybernetics, because I think that as well as this notion of being concerned with all possible machines, and therefore tied up with the very, very mechanical, it is also not really a collection of facts at all. It's a way of looking. And when I teach here at the Bartlett, I don't think I try to persuade people there's a collection of facts or a body of knowledge. I try to persuade them that there is a way of looking at the world which is interesting and productive and helpful and perhaps even beautiful. And so I'm interested in this way of talking. Ernst von Glasersfeld, who's the man who invented the notion of radical constructivism. And then there's one by someone you may have heard of, and I think this also captures something important about cybernetics, and you will see that I'm going to talk about circles and circularity and cycles a great deal in the next half hour or so. Well, we're going to leave cybernetics, at least we're going to leave it as a package like that, and I want really to move to pattern. Pattern was something that I mentioned in the little announcement that we had for this event. I want to talk about pattern, and I want to talk about it particularly through the black box. And I'll tell you why I think pattern is so important, but not just straight off. Up here in this slide, there are 4 types of black boxes. And the term is, it's understood in many different ways. The one on the left is the one like finding out if you've got a bomb and if it's likely to explode. The one on the right is the black box theatre. The one at the bottom, I'm always very charmed by this one. This is the black box that you have in aeroplanes. And this is Dave Watson, who invented the thing in the early 1950s when the Comet jets crashed. And this is a flight recorder. And for some reason, it's called a black box, but it's always orange. So, very strange. And the one at the top, in the middle, I think probably is a black box. Now, that black box was invented as what's called a Gedanken experiment, a thought experiment, by this man, James Clerk Maxwell. James Clerk Maxwell, I think, is one of the really, truly, heroically great figures of Western science. He only made 2 mistakes, and one of them was to be a professor at King's College instead of here. It was clearly, he was badly informed, and obviously he felt he needed to be near the river. Perhaps it was the sewage which appealed to him. So that's Maxwell. And Maxwell invented the black box, as I said, as a thought experiment. And according to my friend Albert Müller, who is the most amazing source for absolutely everything, you don't know where something came from, you write to Albert, and he tells you. And I had tried for years to find where Maxwell had first mentioned the black box, and I'd never found it, and Albert found it in half an hour. So thank you, Albert. The black box is actually an extraordinarily powerful thing, and it's extraordinarily simple. This is Ashby, who described cybernetics as the study of all possible machines. He was an English psychiatrist, and probably the brightest of all the early cyberneticians. And here he is saying, in effect, that perhaps this is a model for science, and I think those of you who know Popper's notion of conjectures and refutations will find that the black box is outperforms entirely by making conjectures, or having you make conjectures and then refuting them. So it's a very good model. And we'll just have a look at a black box working. Some of you will have seen this because I always give the same example, but here it is. And I heard someone laughing at something there. I think someone's cracked what's at the bottom of the page already. Okay, here we have a black box, and we're going to put something into it and see what comes out. This is a real behaviorist sort of thing. It's why the behaviorist psychologists like black boxes, but I think they just made a really critical mistake. They believed the thing was there, whereas it's only an idea you're playing with. So let's start by putting a number in, and we put in 1 and we get 3. And this is the point, this is community thinking. So I'm going to ask you all to start seeing if you can work out what number's going to come next. It's really, don't find it too intimidating, please. So we'll take 3 and put it in. And we're going to get... Got your bits of paper out? You're working this out? It's difficult, this. It's difficult. Sorry? Ah, well, you see. But if we put 5 in, well, on this occasion, we get 7. And now we'll keep Paul happy. I'll put 7 in. And you can tell it's going to be fun because 7 spins instead of just going there. This is semiotics. We'll put it in, and yes, we get 9. You're just too quick, Paul. You leave out too many steps. And so what we have is, I guess you all thought of this, it's an odd number generator, or I can just say that we're adding 2. It's the same thing. But note that those are 2 different descriptions. Okay, now if I'm going to be a good scientist, I'm going to test this result, aren't I? So I might try putting 7 in again. I get 11. Well, I expect you all know what that was. That's the black box, the prime number generator, for instance. Or it learnt last time and it can't be bothered to say 9 again, so it adds 2 again. Or something. The point is that the description of what's going on isn't what's happening in the black box, it's what's happening in my head. It's happening in your head. You make that description. You have no idea what's going on in the black box. And actually nothing's going on in the black box because, as Captain Beefheart said, it's not really here. It's a thought experiment. You're just playing. There ain't no black box. It's just something on a bit of paper. So what's interesting is that the description, you can make a description. It's called finding a pattern. You make a description, and that description is good for what has been in the past, but it is not necessarily good for what will be in the future. In other words, the description can't be taken as being reliable. I mean, it might predict right, it might work next time, but it also might not. And what that brings us to is the notion of viability. That is, that certain descriptions are viable and certain are not. A viable description is one which will go on working. Okay, let me try again, because I'm really a bit confused now. And I put in 7, and I get Ross Ashby, which is all a bit strange. Well, who said it should be a number? And if I now take Ross Ashby back, let's see what happens when I put him in. Now, I have no idea what Ross Ashby sounds like, or sounded like. I never met him. But let me tell you, I'm sure he didn't sound like that. So I'm sure that I am wrong, but intentionally wrong with his voice. What I think is interesting here is Ashby is saying, this is the man who talks about cybernetics as studying machines, and Ashby is saying, hold on guys, what we're actually doing when we study this is we're studying not what happens in the black box, but what happens between the black box and the person doing the studying, the investigator. So, we know that any description that you can produce is okay, as long as it works, and that we produce that description, and that since there isn't really anything there, it's based on nothing. It's based on a wonderful, profound ignorance. And I find that enormously comforting. We can build these great piles of knowledge that we have. Absolutely fantastic things, just this amazing stuff. We build it, and it is based on nothing. And that means, really, that we have choices about what we're building. So it means that even in something as apparently mechanical as the black box, as mechanical as the black box, even in that, we are part of the process of observing, of deciding what's going on, and we have a great deal of freedom, which we didn't think we had when we were dealing with something mechanical. Now, some of us in this room are old enough and alien enough to UCL to know this number. Yeah? This is the telephone number of the Architectural Association in the 1960s when we had proper exchanges, and the number was 0974. And for years, I thought to myself, there's some pattern in this. I know there's some pattern in this, and for years I couldn't work it out. And when you look at that, does anyone see a pattern in there? No? It's terribly, terribly easy, but of course these things are easy when someone's shown you.
But I had a weird feeling that I knew that number, and of course I realise now it's a museum, yeah. But you have to tell me, I couldn't work that myself.
Oh, there we go. The difference between the numbers is constantly increasing. And so 0 to 9 is 1, 9 to 7 is 2, 7 to 3, so 4 is 3, and 4 to 0 is 4. It's amazing. So you can go through it and you can make it all come out ones. So you can be really silly making patterns and obsessive and so on. Now my point is not that this is right or wrong, it's a very silly thing to have done. But my point is that human beings like making patterns. We like using the black box. We like working out what's happening. We like to make patterns. It's actually arguably the most fundamental of all human activities. If you think of it, I don't know if any of you have looked at a newly born baby. Its eyes don't focus and they don't move. Yeah? Newly born babies don't see. They may get light on the back of their eyes, but they don't see. The light doesn't mean anything to them. And what babies do is, over a period, they learn that this strange thing, which you and I would call mother, or they learned that experiences, sorry, let me just start that again. They learned that a whole set of different experiences can be put together into something that you and I would call mother. Yeah? So different parts of the body, different facial expressions, different clothes, different haircuts, different makeup, coming from different angles. All of these things, somehow or other, babies are capable of joining together to turn into something which they will call mother. This is an extraordinary feat. And the strange thing is, of course, none of us can remember any of this, because you have to have done quite a lot of this and abstracted from it and so on before you have what we would call memory, or the ability to explain things. Excuse me. So, we have this amazing ability to make patterns from different experiences that we have. And that is called object constancy, or preservation of an object, or conservation of an object, or object permanence. If you were listening last week to Melvin Bragg on Radio 4, you'd have heard a whole program which they were talking about object permanence, which is what I've always called object constancy. I was making the slides for this, so I had an excuse not to be doing something serious, and therefore to be listening to Melvin Bragg. Now, it's an amazing feat. It's something which we, of course, can't imagine ourselves back to, so we rationalize ourselves back to. But there is this extraordinary ability that lies at the basis of our ability to be in a world, which is to take different experiences and to compute relationships between them, and to say at a certain point, that is permanent. That is something which goes on. And now we do it with extraordinary skill, because all of us in this room, you know, can do this with almost complete strangers. I mean, I'm very bad at it, so I'm no one to believe, but there are 2 or 3 people here this evening who I have recognized. I'm not good at the names, so I've forgotten the names, but I have been able, even though we only met once and it was many years ago and somewhere completely different, to say, we know each other, don't we? It's an extraordinary sort of thing. Across time, wearing different clothes, much, much older, much, much fatter. Well, me, no one else. Now, this notion comes from Jean Piaget. Jean Piaget was a Swiss biologist who got interested in child development. And he became the psychologist who most explained to us about child development in the 1950s, 1960s, 1970s, and 1980s. One of the most frightening things I ever did was to do a presentation, not to Piaget, Piaget didn't travel then, but to his chief honcho. And Gerard de Zeeuw, who is there, rescued me at the end of this by asking one of those wonderful Dutch questions which fills up all the available time in the asking, so I was saved having to answer. This is a form of Dutch generosity that I think you should know. And if you ever go to a Dutch doctoral examination, you'll see if the examiners like the student, because they will ask questions that fill up all the available time. So thank you, Gerard. Piaget is famous for talking about the development of children, you know, this thing about pouring water from a short fat jug into a tall thin jug and asking children, is there more or less in one or the other? This sort of thing. And sometimes people question the way that he described the development of children. But I don't think that's what's interesting about him. I think the thing that is enormously interesting about Piaget is this. It's object constancy. It's understanding that we populate our worlds with things that we create from experience. That's what we have. We have experience, and we make these constant objects, and then we place them outside ourselves as if they lived separately from us. It's not to say that they don't live separately from us, but all we have is our experience of them, which we come to say of them, that we have our experience. So I consider this to be the most extraordinary intellectual achievement, to see this. Now, what we're doing is we're finding patterns. That's what human beings do. And I asked the professor of Latin at UCL if she could tell me how she would translate, instead of, Homo sapiens, doesn't fit many of us, does it? How she would translate man, the maker of patterns. And I was, I'd expected something, but I hadn't expected this. Now, I didn't brief her. I didn't say, let's get the word design in there. She said the best translation for man, the maker of patterns, is Homo designans. And so that brings making patterns and design together. I find that wonderful because I actually think we design the way that we think. And so after finding patterns, I think we then compose those together. And so for me, design is the most fun, is along with creating these constant objects, is the other really fundamental human activity. But it's not on bits of paper, and it's not buildings, and it's not clever stuff. Well, it is. It's very clever stuff, but it's not the sort of externalized design. It's the business of designing the way we think and what we think. So, just by way of a sort of summary, here is a quote from Heinz von Förster, famous cybernetician. We'll come across him again in a little bit, describing what it is Piaget had told us. And just in case you think it's only cyberneticians who come up with stuff like this, only we who could be so silly, here's someone else who's famously silly, saying much the same thing, but rather earlier. Okay. I'm not sure that I should have left this bit in, but I'll get through it very fast. One of the areas of our endeavor that really points to the importance of pattern is the study of randomness. And randomness is nowadays defined like this. And the way in which you test it is like this. Now, what this means is that if you have a string of random numbers, if you can make another string from which you can derive this long string, and this other string is shorter, then that long string of numbers was not random. The important thing to note here is that you can never prove something is random. All you can do is show that it hasn't yet been shown to be not random. It's a bit like, some of you will remember with mad cow disease, certain really silly ministers of one political party, certainly, going out and feeding their children hamburgers in order to show that there was no way that the sort of disease that the cows were getting could be passed on to humans. And then they discovered Creutzfeldt-Jakob's disease, and they discovered that it could be passed on. You can't prove a negative. You can only prove it hasn't happened yet. So the opposite of random is pattern. That's exactly what you're looking for. So our concern with randomness and our attempt to prove or disprove randomness is actually an indicator of our wish to find pattern. And I thought this was very nice. It was on the website on Monday, on our website. And it's just busy telling us that, you know, something to do with vision that we thought was random isn't. It's just, we're doing it. We're doing it here. Okay, I'm going to go back to the black box. And back to Ashby. And here's something else that Ashby had to say. I think this is extremely important. Ashby looks to everyone like the hardened, most traditional, solid sort of physical scientist that the cartoon books can draw. I say that because I am aware that when we talk of scientists, when I talk of scientists, I frequently am really grossly oversimplifying and, in a sense, libeling science and scientists. I don't mean to do that. So, here's Ashby on what happens when we look at the black box. As I said earlier, it's not just the black box, it's us, the investigator, in the black box. So, let's look at it like this. The black box is square and above, and the observer is round. Well, what happens is exactly what happened with the numbers that I was putting through that black box. The numbers, you know, they may have, something happened in the black box, or I like to think of it in that way, but I had to take the number and put it back in. Yeah? I was complicit in everything that went on. And so what happens between the black box and what Ashby calls the investigator is that there's a circle. There's circularity. You remember me mentioning circularity at the beginning. So here we have the black box and the investigator, the observer. Now, let's just think about that. The black box remains black. I mean, the black box isn't really there, but in as far as it is there, I never know what happens inside it. All I know is what's happening between me and it from my point of view. So, in a sense, if I'm looking at this, then I've just got another bloody great black box. And I could go on with this. I'm not going to. I'm going to do something else with it. For those of you who've seen me parade my black boxes before, I promise you something slightly new. And I think it's appropriate to bring up this wonderful Heinz von Förster aphorism at this point. Objectivity is the delusion. We have, in the West, been inclined to talk of knowledge without people knowing. We've been inclined to talk of observations without someone actually doing them, of experiments without experimenters, and so on. And Heinz here is just reminding us that there couldn't be an observation without an observer, and to pretend that there could be is to be deluded. Well, that, by the way, is Heinz von Förster. Good. Now, let's just... One of the students who I'm teaching this year was kind enough to take my drawings and put them into this projection for me, so thank you, John T. My computer fell out of the rack above the seats on an aeroplane 2 weeks ago, and it's only this morning that by going to meet UPS in the middle of Portsmouth, it was sort of like a naughty assignation, I was actually able to get a new one. So I have been without software and without the ability to do almost anything, working on borrowed machines and my wife's machine strapped up to other disks and goodness only knows what. So John T. very kindly did this for me. And this, as you'll recognize, is the diagram we've had before of the observer and the black box, just put on a plane, because I want to talk just a little bit about this notion of the observer. Here we have an observer Above this, you remember that I said it was a black box, and it contains a black box. And what we have is this. We have the traditional notion of the observer, which is the observer of something untouched by it, above it, somehow looking at it, but with total independence from it. It's the observer of. What cybernetics proposes is that actually we should think about the observer in. The observer in is like this. And from that, that change in the way of thinking about the observer, the sort of, for instance, reflecting the way that Piaget says that we form patterns from experiences and then create constancies amongst them and so on. That leads us to a distinction between a cybernetics of observed systems which just look and they say, here's an observed system, and systems which are involved in the process of observing. My differentiation is to talk about of and in the system. Heinz von Förster talks about observed and observing systems. Now, I want to take that notion. I don't want you to read the whole, well, please read the whole of this text if you like. It's a very nice text, and I think there's one typo in it. This is Margaret Mead. How about if we maintain the consistency of the circularity also in our observing? I find this particularly ironic as the current president of the American Society for Cybernetics. I'm dealing with the society she actually talked to in 1968 when she presented this argument. And what she's saying is, you know, why don't we do things a bit differently? Should we still be going on and so on? And here we are 42 years later, and the American Society for Cybernetics is absolutely typical of any small society. It has no cybernetics in it at all. It is completely conventional, and it really looks to me, as president, but please don't repeat this, as if it probably should have died about 30 years ago. I keep trying to revive it, and one of the things I'm going to do is run a competition to ask people what a little society would do if it were to believe what Margaret Mead says, take it seriously and act on it. So, okay. The black box, as I say, is a Gedanken experiment. It's a thought experiment. It's not something solid. It's not a box you put on a table. It's a device you use that allows you to adjust behavior so you have an input and an output. And, yeah. This quote from Heinz, I think, is trying to get at that point. What he's saying is that there are certain sorts of situations in which it isn't possible to decide. For instance, if you believe that we as observers live in a world of experience, that that's what we're dealing with, and that we make stuff from experience, we make objects which appear constant, then there may or may not be an actual physical object that matches this, but we can never know that. Just as we can't know what is to be observed without ourselves being involved in the observing. So we can't talk about what a mind-independent reality might be. We don't know that. We are involved, and because we're involved, all we can know is what we can know through being involved. We can't talk about that sort of given reality, although we can choose to believe in it if we want. There are lots of questions that come up if you take this sort of position. I'm going to deal with two of them, and one of them I'm going to deal with very, very fast. And I'm going to leave out the rest. You know, this is supposed to be an entertainment for you, and we're already running a little bit too long. So I'm going, first of all, just to take you through this. The question I have to ask is, under these circumstances, how would you be able to design or explain how we, all looking differently at the world, believe we see the same things? And that's what my cybernetics PhD was about. And 40-something years afterwards, I still find this incredibly difficult to explain. And I have to say, it took me, for those of you who are doing research degrees, I shouldn't say this, of course, you all have your research question. It took me 20 years after I'd finished writing my PhD to find out what the research question was. So, shh, I'd never said that. The question is, you know, I'm living in a world where I say, I observe this. What do I need in order to be able to say that? How could there be an I that I can talk about who can do this observing? And the answer is, well, if we are dependent on observing, then I have to observe I, whatever that means. And similarly, if I am to believe there is a this, then this has to observe this. Now this, I'm not talking about having eyes. I'm talking about a set of logical conditions, and I'm not really sure what they mean. The result of that can be shown in a way like this. This is why I'm not trying to go through this much here. You end up with things like this, which are sort of types of formal statements. I'm including them because I want to show you that there is a way, or that I believe there is a way, that I can answer the question, but I'm not trying to answer it for you, because I think that you would go absolutely crazy if I started presenting you with this and talking about it at length. But this one I will do. This one is much easier, and this is due to the wonderful Gordon Pask, and it has to do with communication. We believe that we can communicate and communicate about the same things and exchange ideas and so on. And so we have an important question to ask, which is how would we do this? And this is the traditional notion. This you will all know as information theory, or what was called the mathematical theory of communication. And the thing about it is, well, there's no freedom in this at all. The message is packed in one end and comes out the other end. It's unchanged, and the question of meaning is really very difficult. I mean, where is the meaning? So we tend to say that the meaning is in the message. Sounds very McLuhan-esque. And it is transmitted. Now, I want to present to you a different way of talking about communication, which comes, as I said, from Gordon Pask. Here he is later in life. And I'm going to introduce you to two personae, X and Y. That might be two people, but it might be just you talking with yourself, because I guess that you, like me, do this unless I'm the only madman in the room. Isn't the definition of mad people who talk to themselves? So, the point that Pask wanted to make was that if you don't see things the same way as other people, then you can't exactly exchange meanings. What you can do is you can develop meanings which sort of run in parallel. And he said, how do you do that? And so he talked about conversation. What I'm going to present here is a very strict conversation in which things happen turn and turn about. And so here X thinks, and I don't know if you can see that, but it's sort of supposed to be a tree. Yeah? And X says to Y, tree. Now, and Y hears tree. And so Y thinks, what is tree? And comes up with their own understanding. There's actually no way you can compare these two, so I'm cheating by showing you this as if you could compare the two, because they're entirely internal, and in order to compare them, you have to have some form of representation, and then you run into this thing of how do the words connect to the thought. Y may want to check with X that he or she has understood correctly. Now, if I as Y say back to X tree, it doesn't really mean anything. I'm just sending the same word backwards and forwards, and that means, well, what it tells me is that there's a very good parrot in the room. So I need to say something else. And of course, we all do this in a conversation where we're out with people. We say, do you mean, or let me put it in my words, or whatever. So I might say, for instance, arbor. Those of you who know de Saussure will know the source of my tree example from this. And X now hears arbor and says, arbor means this to me. Is this close enough to what I was thinking of at first for me to say that Y has developed themselves something that I believe to be a similar concept to mine? Are these working in parallel? It's a very clever device. It means that in conversation, no information is passed. You're not sending messages. What you are doing is enabling the parallel building of different, but nevertheless fitting together understandings. For Pasque, it was important that we should understand that we can do this in our head, we can do it between people, but we can also do it with groups. Yeah? So it's quite possible that we are talking in groups, that groups can fit together, and so we know that teams and what have you. So it's important that it's understood that this isn't related to a person, but to a persona. This is one of Pasque's drawings, and there is one which has people conversing. This one's only half a conversation, but it was all I or anyone could find, so we'll skip over it. And just end up with a couple of more points about conversation. The first is this. Well, it's actually the same point made by two people. Yeah, it's this. This is Joseph Beuys, and he was reported as saying that there's no conversation without a listener. Now, you hear people on the radio each morning, well, or the television or whatever it is you do, but you hear people saying, I have made it perfectly clear that. The moment you hear someone saying, I've made it perfectly clear, you know they haven't. Because, of course, they wouldn't need to say that they had if everyone had already understood it. But you also hear a misappropriation of responsibility. It is indeed my responsibility to say things as clearly as I can. But it is your responsibility to listen and understand. And without that, there is no conversation at all. I cannot make your meaning. I cannot listen or understand for you. And when you speak to me, it is my job to listen and understand. What makes a conversation is not the talking, but the listening. Yes, well, there's Heinz's version of it at the bottom. Good. Let me just then compare what happens with that coded, transmitted message and a conversation. I'm just going to show these. I'm not going to talk. And lastly, one of these assumes somehow that code can be hammered into you. It's what a lot of people would like teaching to be about. that I can just take something and bash this information into you. And the other says, no, what we do is we create parallel understandings, or understandings that seem to us to work in parallel, and we have to recognize that the responsibility for this, the responsibility for understanding, lies not with the speaker but with the listener. So you can't blame the teacher. Okay. In the case of a conversation, you are free to construct your meaning, but in the case of the code, you are not free to. It is mechanical. Now, this is going to take us to the area of ethics very quickly. What is wonderful for me about a conversation, as opposed to a coded form of communication, is that the conversation has ethical implications that I really like and value. It has implications of how we behave towards the other. And these implications include that we behave with generosity, that we listen rather than tell, that we don't put ourselves always first, that we tolerate the other, the way that the other expresses themselves, their difference, and that we respect them. And I think that's just a fantastic thing to have today, when we're being told about all sorts of obligations and blind watchmakers and goodness only knows what, to have a way of talking about the world that raises these ethical qualities as being at the heart of what we do, I think that's very, very special. And for the self, this way of understanding that we construct our view of the world, that we deal in conversation, that we have systems, ways of understanding that allow difference between us and value difference, suggests that we need great honesty, most of all with ourselves, that we have to be open-minded, that we accept responsibility, and that we trust ourselves and others. You can't have a conversation with someone if you don't trust them. You may disagree, you may not trust them entirely, but in order to be able to hear what they have to say, you have to trust that they are well-intentioned in saying it. It's very difficult to make it work if they're not. And finally, what do we need between both of us in a conversation? We need the notions of sharing and of mutuality. What benefits me benefits you. Now, what about design? It seems to me that these are exactly the qualities that we admire in good designers and that we look for in designers. And I'm not talking here about things like the old AA's motto, design in beauty, build in truth. Is that it? Something like that. I'm not talking about things like that, but I'm talking about the way in which we think. What do designers do? Designers give more than is necessary. We don't just solve people's problems, we solve them in a way that adds special and extra value. It is essentially a generous activity. It's an activity in which, if we're going to do it well, while we respect and recognize that we have a special contribution, we also listen to and value what those for whom we are working want. And those for whom we're working, of course, nowadays is not just a client. It's much wider than that. And I believe you can go through this list and you can say, these are qualities that we as designers try to develop ourselves, that we believe are important. And so cybernetics and this cybernetic way of looking at the world actually produces, as a natural outcome, exactly those sorts of qualities that we admire and try to develop ourselves. And I think that students in architecture schools see this all the time, you know, the need for honesty when you're explaining what you're doing, the difficulty of learning to be honest about what you have achieved as opposed to what you wanted to achieve and how those go together, and so on. But there's something else that comes out of this cybernetic stuff that I think also helps us as designers. Let me just go back to this diagram, you'll remember it from earlier, and talk about this as a conversation. What's happening here is I have two parts to me, two personae. There's the Y part and the X part, and the Y part is going to draw. And the X part is going to view. So the Y part's talking and the X part's listening, but they're both actually me. They're both in me. I think this explains what happens in sketching. That I doodle a bit and then I look and I'm surprised at what I see. And I'm surprised because I'm holding a conversation with myself. I am both the drawer and the viewer. And because these two are different, they see things differently. And I guess that everyone in this room, or almost everyone in this room, will have learnt that the value of this extraordinary thing of making those first arbitrary lines and looking at them and realizing that they're suggesting something that's way beyond anything that I'd thought, and then keeping on doing this and keeping on enriching. And for me, this was really, as a student, I couldn't understand this at all. But then I was the worst architecture student there's ever been. So any of you who want to be a professor and are here at UCL, you should know it ought to be pretty easy for you. So there is I believe, something like a design conversation that is at the heart of what designers do and that is explained by these cybernetic understandings and models, this notion of finding pattern, this notion of circularity, this notion of parallel understanding. And so I think that we can indeed say that the pattern finder is Homo designans. And I think that when I am accused of destroying humanity and turning everything into a machine, it's not actually quite right. The problem here is that when we say freedom and the machine, too often we mean freedom or the machine. And the contrast that was being made was between freedom and the machine as a division. It's this or it's that. Well, what I hope I've shown you, at least, a good part of it, is that this process of finding out how the machine works can actually provide us with frameworks which allow us far greater freedom than any other way we have tried to explore that notion and to consider how to be free. So I'm going to conclude with this. It's not entirely appropriate in the sense that minds and matter are perhaps not what I've been talking about. Well, the reason I include it is the way that Maxwell ties the two together. He doesn't say that the mind comes from matter or that matter comes from the mind. He says that you need both and they work together. Gregory Bateson, who you may remember was one of the Macy group, used to say this about mind and body. He said, you can't have a mind without a body and you can't have a body without a mind. These things are linked. The observer and the observed are linked. There are circles. These are the things that matter, and they give us a new insight into what it is to be human and to act in the world now. So I will remind you of these two definitions, or whatever you want to call them. and leave you with that. Thank you very much. Away! Have a good evening. Thank you very much for coming.